our last speaker, we have an inspiring young data scientist, Dr. Zafiirah Hosenie, who is a postdoc scientist at Microsoft Research in Cambridge, working in the mixed reality and AI lab. She completed a PhD at Jodrell Bank Center for Astrophysics, JBCA, at the University of Manchester, where she focused on machine learning for astronomy. Born in Mauritius, she did her undergraduate studies in physics at the University of Mauritius. She was then awarded the Square Kilometre Array SKA Master's Bursary and embarked upon an MSc in Astrophysics and Space Science at the University of Cape Town and Northwest University. She has an avid passion for technology, and her research interests include developing automated pipelines using ML for classification purposes in image domain, time domain, and in imbalanced machine learning problems. Zafiirah, you can go ahead and present.
Thank you, Sadia, for the introductions. Hi, everyone. I'm so privileged and so honored to be sharing this afternoon with you all. So I'm Zafiirah. I'm a postdoc research scientist at Microsoft Research Lab, Cambridge. So before diving into the talk, I will just share a little bit about my journey and also my interest into data science. And also I will just give you a little bit about my, I will just tell you a little bit more about the project that I've been working during my master's, my PhD, and some of the work that I've been working at Microsoft. So to start with, so I am from Mauritius. I've completed my degree in physics, and then afterward, I moved to South Africa to pursue a master's in astrophysics and space science at the University of Cape Town and Northwest University. So my master's has been fully funded by the SKA bursary. Afterward, back in 2018, I moved to Manchester, where I've pursued a PhD in machine learning and astronomy. So my PhD has been fully funded by the DARA Big Data. So last year, in the pandemic, so I've joined Microsoft as a postdoc research scientist, and I've been mostly working in the mixed reality and AI field. So my interest in data science started back in, I would say, 2015, where I've got the opportunity to attend my first data science workshop in Mauritius. So from there, I've got the opportunity to move to Cape Town, where I've got the opportunity to be working with Professor Bruce Bassett and Dr. Nadim and the team. And I've got also the chance of attending various workshops in Stellenbosch, in Johannesburg. And during those workshops, I've got lots of opportunities as well, to be working on machine learning projects, including for example, in terms of healthcare, in terms of climate, and as well as astronomy. So during those workshops, I would say I've taken the opportunity to present my work as well, and also to present poster presentation. And one of the pictures here, you will see that I've got one of the best poster presentation during the deep learning in Daba, the first deep learning in Daba in Johannesburg. So this is where I've got the opportunity to meet leading researchers in a computer science field. For example, here it is Professor Nando de Freitas, who is a leading researcher in computer science. And the major takeaway from this slide is mostly for participants when they are attending workshops, I would say for them to enjoy the experience, to learn, to grow, and to network. This is very important. So the next few slides will be mostly about a little bit about the project that I've been working during my master's as well as PhD. So it will be a little bit technical, but not that much. So during my master's, I've been working with Professor Bruce Bassett and Dr. Nadim Muzia on source classification using machine learning techniques. And I would the main aim of this project was to perform classification algorithm of radio galaxies. And we mainly focused on FR1 and FR2, which is Van Allen Rayleigh type 1 and type 2 galaxies. So at this time, when we were trying, it was back in 2016, I think. So when we were trying to use a deep learning algorithm, so we didn't have so much data. And we were having like around 100 of data of these types of galaxies. So this is very challenging to do like deep learning with these number of samples. So we came up with the idea of generating realistic looking radio images. And this is how it looks when we apply generative adversarial network, which is mostly GAN. And we perform the classification. So from there, this is where like this actually triggered my interest in data science. And I really wanted to continue working in this field, in astronomy and machine learning. And this is where like I've applied for the DARA Big Data funding, I would say scholarship. And this is where I've started my PhD at the University of Manchester, where I've started working with Professor Ben Stappers and Dr. Robert Lyon. And during my PhD, I've got the opportunity to also work with leading researchers in Netherlands, Cape Town, UK, on transients and variable stars classification. So the question one will ask is why we are using machine learning in astronomy. So the first one is we are receiving a large amount of data. The second one is transients and variable stars are, I would say, rapidly fading sources. As you can see in this animation, you will see that these are only visible, like you will note that time series data, these are only visible for a very limited amount of time for follow-up. Therefore, we'll need to have like an algorithm to be able to detect that at very early stage when these are being like observed. And in the false detection pipeline, we have noticed that we have large amount of noise data. So we need to find a way of getting rid of those. This is where, like with different researchers from Netherlands, Cape Town, we came up, and then UK, we came up with the approach of getting a pipeline to work in an automated way. So in this, we have developed like MIRCRAP, which is where we use the MIRLIC telescope and we gather data, and where researchers have been labeling those data, and we have been using like a supervised approach to be able to classify between, I would say, interesting objects versus noise objects. So once we have trained the data, the algorithm, and we have evaluated our model, so we use the model and we deploy that into like runtime. So the idea is we want to remove like a human in the loop. And this is where like during, I would say, during observation, so these data will pass through different processes, and we'll use that algorithm to be able to perform prediction, whether it is aerial or focused. So I would say the next project that I've been working is mostly on localizing and detecting objects in images. So I've been applying these techniques in computer science to radio astronomy, where I wanted to not only classify between objects, but I really wanted to get more information in terms of the probability of the objects, the location, as well as the mask. Here in this project, what our aim is we really wanted to get the location of that object, which is false radio burst here, and we wanted to classify between FRB and then RFI, which is mostly noise. So we pass that through a network which is known as MOS RCNN, and then at the end we got like the location of that object, that is false radio burst here. And then we'll get the probability that it is like an FRB, and then the mask. The mask here will be very useful in terms of gathering statistics of that source. That is, for example, the dispersion measure all the time from that image. So these are some of the results that we obtain from this algorithm. So you will note that from that result, we have managed to get the location of that particular objects, and then from there we get the probability that it is an FRB, And then we can calculate, based on that loss, we can calculate some statistics, that is the dispersion measure and time here. And these can be used further for further analysis, like what types of sources and so on. And like when I've been working on these projects, and I've seen that my interest in terms of data science, algorithm as well as technology has continued to increase. And in parallel to those projects, I've been working mostly like on other projects, including health and climate. So these are, I would say, projects that actually increase my, trigger my, how would I say, my interest in data science. And this is where, like, after my PhD, I've transitioned from astronomy to mixed reality. So when we refer to mixed reality, what we are trying to say is that we are referring to the blending of our, I would say, physical world and digital world. So mixed reality devices such as the HoloLens or virtual reality devices will allow us to render, like, for example, here an animation where we can see we are rendering like a bird into 3D in front of us. And you can imagine that we can also render a person, and they will a person in your room, and they will look really like how they would actually appear. So last year, Microsoft announced about like Microsoft Mesh. So I will just play a quick video to introduce you to Mesh here.
Right now on the same trajectory. As we put people first, technology fades into the background and feels like anything but. Aisha, what do you think? I think we're gonna head through 30, maintaining 2800. We'll be clear for approach. Excellent. This changes the way we see the world, and in turn, changes the world we see. These numbers are looking great, actually. There's promise in the possibilities, and what we see and create next will stretch the imagination. Good morning, Sarah. Morning. Slowly coming towards the top. A world without boundaries. Good job. A lot better than yesterday. Yeah. Excellent. Slow to bring. A world where technology enhances, not limits, humanity. With people front, center, and in the spotlight. The future is here, and here can be anywhere. Introducing Microsoft Mesh.
So I hope that this has given you a little bit like of an idea about what Microsoft Mesh is and the kind of technologies that we are talking when we are speaking about like social presence. So it is really about like enabling people to, I would say, come together, and even though they are remote, and they will be able to share like a 3D experience, and you will feel like the remote people are actually with you through technologies such as like avatars and holoportations. So as a last note, I would say that we are hiring. So for both full-time and internship opportunities, both in Cambridge and other locations. So if you would like to learn more, please browse through those links and enter the location of your preferences. And if you want more information, please contact me. Thank you so much.
Thank you so much, Dr. Zafiirah. I think the slides will be shared with everyone and they can get the links where they can apply for those opportunities. This leads us to the Q&A session. I will just read out the questions from the Q&A to the directed